Okay, so this is going to be 2, 3, and sum of 2, 4. We're going to talk first about rate of change and slope. Rate of change, you're going to have to identify, given data, what is domain and range, or domain being the independent variable and range the dependent variable. And that is rate of change will be described as change in y over the change in x. And this is directly related to and is slope. And here is the slope formula. Slope is your change in y coordinates over your change in x coordinates. I believe that's what rate of change we just talked about being. And so if you have 2 points, we can find 2 points on a line. You have the y coordinates, y2 minus y1, over the x coordinates, x2 minus x1. So rate of change is slope. So here's our first example. You have this recreation. The graph to the right shows the number of gallons of water in a swimming pool as it is being filled. At what rate is the pool being filled? First, let's look at something. You're given this graph that you should be able to pull points out of. You could also be given the same information in a table form. We have just gone over that, different ways to represent a relation or represent a function. So you can have the table form, you can have the graph form, just like this. So be prepared to read the functions or relations in their various forms, the maps, the graphs, list of points, to be able to find your rate of change. So here, let's take a look at this graph. These are given straight out for you, but you should be able to read along your x and y axis and come up with these points. So let's use the slope formula, or rate of change, the change in y over the change in x. So we have our y values, 252 minus 108, over the corresponding x values. So 252 is paired with 7, 108 is paired with 3. You do not want to mix those up where you have plugged this or substituted this into your slope equation incorrectly. And we simplify this, we get 144 over 4, and that comes out to 38. And that is the rate of change. So what does that 38 mean? Well, if our y values are water, and that is over time, then that means we have 38 gallons per minute. So it's pretty fast. Okay, we're also going to be writing linear equations. So we'll be taking what we did. 2, 3 is all about finding rate of change from various word problems or just from graphs. And we're going to use that to write linear equations. If you know point and you know the slope, you can use what is going to be called point-slope form. You can replace in this very long equation variables y1 and x1 and your slope values with the slope and point values. You'll then simplify that equation using distributive property, combining like terms, and then your final simplified answer will be your slope-intercept form. And you'll be often asked to find or write an equation in slope-intercept form, and that's what you're going to end up with. First, very simply, if you have a graph, you should be able to write an equation just given a graph. The first thing you can pull off of this graph, just looking at it, is this point. If it crosses the y-axis the way they have shown, then we can find this is the y-intercept. Next, we should be able to see a change and be able to identify the slope. You should be able to see, okay, well, how far up and over, because slope is defined as the rise and run. Pay very careful attention in your book and any other place where you were given a graph, how they scale, because if you look carefully, your y's on this graph, they're scaled by 3s. This x is scaled by 2, so be very careful as you are counting and taking into account what is our change. So let's look. What is this change in y, which we had just done on the rate? Well, coming from this y-intercept all the way up, I need to go to another good point, and this is the best point. All these others are some fractional kind of point values. I really don't want to use those. This is my next best point. It's going through these perfect grid lines, which are at whole number values. And that's what I like to use. So that change in y is up 24. This is obviously 15 up to the origin, and then this goes up. These are by 3s, up 9. So 9 and 15 is going to give me 24. What is my run? How far over am I going from here to this point? These are by 2s, and I've gone over 6. So I can simplify this up 24 over 6, and I have a slope of 4 over 1, which is 4. Well, if I have this y-intercept and I have this slope, you should know the slope-intercept form of a line, y equals mx plus b. I have slope as my m. B is my y-intercept here, 0b. Well, I have 0, I have a b value. I should be able to put those into the equation. Slope next to my x, that's my mx, and I can put the b value from the y-intercept into this constant spot, and you can put plus negative 15, or we can just simply put minus 15, and that's the equation of this line that is graphed. Okay, if you were given a point, write an equation of a line through 6, negative 2 with a slope of negative 4. We are going to use, this is the point slope form of the equation of a line. So you use this when you are given a point. We can identify this as x1, y1. So here's a spot for that x value and for that y value. And we have a spot for the slope. Now this x and this y will remain as variables. So we fill in our y value from the point 6, negative 2. We fill in our slope of negative 4. We fill in our 6 from the x value of the point. It's simply simplifying that equation. We have some distributive property. We have a minus a negative, so we simplify that distributive property here. We need to get y by itself. That's the only other thing I can do to get this equation of a line. We'll express it as a slope-intercept, y equals mx plus b. And to do that, we need y by itself. So this 2 collected with the like term over here of the 24, and I've got negative 4x plus 22 equal to y. That's the slope-intercept form for this line that has a slope of negative 4 and passes through this point. I can also write an equation of a line if I have 2 points. You have already spent time finding rate of change, finding slope. So first of all, you can take those 2 points and find the slope. So you've got y values, you've got x values. So let's put in negative 9 minus a negative 4 over the 4 minus 2. Now, of course, you should know you can reverse this. What if you had done negative 4 minus a negative 9 and then 2 minus 4? Yes, you will get the same answer. Initially, you might have opposite signs than myself. You might have a negative 2 or a positive 5 over a negative 2, but that's still going to be a negative 5 over 2 as a final answer. That will be the same slope. This negative sign can be a negative 5 over 2. It can be a negative out here on the entire fraction, or it can be 5 over negative 2. So that negative sign can move around in this fraction. So we've got the slope. We have 2 points we can choose from. We only need 1 for this point slope equation. So I just have 1 point that I need to plug in here. So I'll just use 2, negative 4. Why not? I've got my slope to put in here. I'm going to distribute that. And negative, negative, that's a positive. I'm distributing this, negative 5 over 2x. And if I do this negative 5 over 2 times 2, this is a 2 over 1. So that divided by 2 and then times 2, those are going to cancel out. And I am basically left with 5 over 1, which is 5. You can check that on the calculator. We can do it on a board if you want to ask questions later. I need to get y by itself. I need to move the 4. And what you have is, of course, the 4 goes with this 5. You're left with 1, and here is your equation of this line. So you've got 2 points. Get your slope. Put your slope in, substitute it into the slope-intercept or point slope form, you only need one of these points. Now, could I have used 4, -9 in here? Yes, I could. Am I going to get this equation? Yes, I will. Now, both of those points are on that line. Now, we have another set of conditions. We can write an equation for slope-intercept form for a line that satisfies particular set of conditions. We can write equations of lines for perpendicular lines to another line given, or for lines that are parallel to another line given. So I want an equation for a line that passes through 3, -1. And there's this other line that is drawn out next to it. That is y equals -1/3 x minus 4. My line that goes through 3, -1 is perpendicular to this line. Perpendicular means that they intersect at a 90-degree angle. Perpendicular lines have negative reciprocal slopes. So this slope of this line that I need to write the equation for has the opposite slope. Its sign is opposite this. So if this is a negative slope right here, because this is in slope-intercept form, so right here is my slope. So the slope for this line is not going to be negative, it will be positive. I also need to do the reciprocal of this slope. So I should flip this over. So the slope that I will use in this problem will be +3, because perpendicular lines, which is what this line that I'm writing the equation for, its relationship is to this line, have opposite reciprocal slopes. So I'm going to use this point because that's where my line passes through, and it is perpendicular to this line. Perpendicular lines have opposite reciprocal slopes. So my slope is 3. Here's my point, and then we need to simplify. Now, parallel lines have the exact same slope as each other. So here's my line that I need to write an equation for. Passes through 1, -1. It is parallel to this other line. This other line out here passes through the points 4, 1, and 2, -3. So my line, which I need my equation to run through and use, has 1, -1. The line that it is parallel to, which is going to give me information about my slope, goes through 4, 1, and 2, -3. So parallel lines have the same slope. I need to use these 2 points to find slope, and if parallel lines have equal slope, then I don't need to do any reciprocal or opposite sign or anything like that. So I'm going to take 4, 1, and 2, -3. My y values, my x values, changing y, changing x. I'm going to simplify this, and I get a slope of 2. Parallel lines have the same slope, so I'm going to keep the 2. And my line passes through 1, -1. It's parallel to this line. I have used these to find slope. I'm done with this information. Here's my point slope form. I need my 2 because parallel lines have the same slope. I'm going to plug in that, or substitute in that slope and the point that my line passes through. I'm going to simplify my equation. And I have my equation. Y equals 2x minus 3. Just to review, parallel lines have the same slope. So you have this information here about the line that your line you're writing an equation for. It has this relationship to it. Okay, so your line you're writing an equation for, it's parallel to this one. So this gives you information about your slope. So you need to find your slope.